Okay, here's our batch mixer simulation, and what we have here is the little simulator, and the way it works is, the requirements for it is we have selector switch A, B, C. When we're in position A, pump number 1 fills it up, the tank up to the amount on the thumb wheel, and pump 2 fills up the rest of the way until it's full. And then we run the heater and the mixer until we come to our temperature here. So we have mixer, heater. And then we empty the tank with pump number 3. The LCD should display the amount filled by pump number 2, which is the total amount that we pump out, minus the amount that we put in from pump number 1. So it's total minus thumb wheel equals LCD when we're in position 1. Position A. When we're in position B, nothing happens, it's just idle. Position C, same as A, except the heater doesn't run. We just mix it with the mixer for 4 seconds, and the LCD just displays the total amount in the tank. Now, because this one's more complicated, I thought that I would put in this thing, which is General Plc Design. And what we have is, the first step is to make a sequential functional chart, which is basically a state diagram. It shows the different states and then what transitions between one state to the other one. And then you develop a functional block diagram, which is a grouping of circuits, like-minded circuits into the functions, the ones that control the motor circuits, the ones that control lamps, your counters, timers, that type of thing. And then finally you get to the ladder logic, which is the actual implementation that we do. Now, also on here, and first I guess to show that, what we've got is, for the functional or the sequential diagram, looks something like here, and it's just a pictorial. But first we start out in the idle if we're in switch B or reset. Then when we get to start and low level, we go to pump 1, we fill it up, and we count how much we're filling until we get to the thumb wheel switch or high level. Then we turn 1 off, turn 2 on, and we do that. And depending on where we go here, on both of them, when we get to a high level, we do one of two things. We either go to the temperature sensor, in which case we have mixer and heater, or we just do the timeout with mixer only. Then when we finish that, we turn on the output pump. We count how much we're pumping out. And when we get to the low level, the tank's empty. We subtract the value in pump 1 from the total amount. And finally, when we're all finished, we load one of two values, either subtracted value when we're not in position C, or the total amount of the tank when we are in position C. Now the functional block diagram, here we just have our start control or stop control logic, so this turns everything on off. And we have 4 sections that the program goes through. It has the fill when it's full, the unfill stage, and then the when we've finished the total cycle, and that's just to do some housekeeping. So we fill it up, and we fill it up based on what's in the thumb wheel switch, and we put that. And here it's different when I was doing this after post-production of when we did the actual program. I was saying, well, we should put that in the preset value. The actual implementation is a little bit different. I put in a register, and then I have that register compare with the accumulator, and then when the comparison is equal, then I stop the pump. And this is probably the better way to do it, is put it in preset. But anyway, when we fill it up, there's pump 1, pump 2. When we're full, then we use our mixer and or our timer, our heater. We don't always use the heater. And then when we're done with that, then we go to the unfill, and then we just count how much we pumped out. And then finally, depending on what position C is in again, we either put into the LCD the total amount minus how much pump 1 put in, or the total amount, and we put that in the display, and that's part of the housekeeping stuff. So if we look at our program, what we've got is, if we go and we load our program, put it into run mode, now we can put in any value here. We'll just put in 100. So pump 1 should pump to 100, and then pump 2 will pump to the final. Now it should take about 306 to fill it all up. So we enter that value, and we start the process. Our run light's on, And when we're finished, we get 207, so it's about 306, 307. And we can change that value, and then these things will change accordingly when it finishes. So now it's 200 by that pump, 100 by this one. And you can also tell by the duty cycle on each of these how much they pump. And if we're in position B, nothing happens, and we're in idle, and nothing happens when we hit start. We're in position C, and we start it. Now the only thing is, this display is just going to display the total amount, and that's the way it works. And now we have the if we're full, so if we try to overfill it, we can't, because there is a fill signal. And so what happens is pump 1 is always on, pump 2 never comes on because we're trying to fill it, but we don't overflow it because we have the fill complete cycle, which stops our pump number 1 from pumping when the fill complete cycle is done right here. So that's the way the program works. Now, one of the things I'm going to do in posting in these things is, rather than just show the simulation, I'm going to post a PowerPoint which actually has all the coding, so you can take a look at that and see exactly how it's done. And as always, there's a million different ways to do it, so this isn't the best way. In fact, it's not preferred. As I already said, we had the one value going into a register rather than going into the preset value, so this program isn't quite right. But this one also, I just want to point this out, it makes use of this bit, which is a status bit, but this is a first time scan bit, and this is like a power on reset value that you can use to clear registers and just start off the cycle. And it's a pretty useful bit, and you should use it. And that is it for our mixer batcher simulation.